Supplemental restraint systems can be extremely dangerous. When working on or around these systems, always assume the system has not been disabled. Always follow manufacturer's recommendations and procedures. If in doubt, do not touch the system. When diagnosing any problem in an SRS or supplemental restraint system, always follow the manufacturer's procedures for disabling and handling airbag components. Diagnosis should begin by confirming battery voltage is within specifications. Using a scan tool, observe the airbag deployment loop data. If the resistance value is high on one of the squib circuits, it will be necessary to perform the following checks. We need to isolate the open or excess resistance to either the airbag assembly, harness and connectors, clock spring, or the SRS control module. Observe the scan tool data parameters while turning the steering wheel from lock to lock. If there are any spikes or dips in the squib circuit resistance value, then the clock spring will require closer inspection. Following the manufacturer's procedures, disable the airbag system. A wait time will be required. Remove the airbag assembly and store in a safe location. Insert an airbag simulator or dummy load in place of the airbag. Re-enable the SRS and observe the data display. Remember to perform a wiggle test at each connector before disconnecting. Watch the scan tool while doing this. If the resistance value returns to specifications, then there is excess resistance or an open in that connector. If the resistance value has changed to the specified value with the dummy load fitted, then the open or excess resistance is in the airbag assembly or the connection. Check for corrosion or correct terminal tension before replacing the airbag assembly. If the resistance value has not changed, turn the key off and locate the next connector in line and disconnect. Insert the dummy load here and turn the ignition on. If the resistance value on the scan tool is now OK, then the open or excess resistance is in the clock spring or connector. Again, check for correct terminal tension and corrosion before replacing the clock spring assembly. If the resistance value is still excessive, turn the ignition off and disconnect the SRS control module and the dummy load. Before commencing the next test, ensure the airbag has been removed from the circuit under test. Connect the multimeter, set on ohms, between the low side circuit at the SRS control module harness connector and the last disconnected harness connector. Perform a continuity test here and observe the results. If the excess resistance or open circuit is displayed here, then the fault is in the harness between the two connectors. If this circuit is OK, perform the same test on the high side circuit and observe the result. If the excess resistance or open is displayed here, then the fault is in the harness between the two connectors. If both circuits test OK, then the excess resistance or open circuit will be in the SRS control module or harness connector. Check for terminal tension and corrosion before replacing the SRS control module. Be very careful when performing terminal tension checks on SRS connectors. There is a grounding bar in each connector that may be damaged if this is done incorrectly. If the resistance displayed is lower than specifications, again rotate the steering wheel while monitoring the scan tool data. If there are any spikes or dips in the squib circuit resistance value, then the clock spring will require closer inspection. Disable the SRS following the manufacturer's procedures. Remove the airbag assembly and store in a safe location. Disconnect the SRS control module. Using a multimeter set on ohms, test for continuity between both terminals of the affected squib circuit. If the circuit displays open or infinite resistance, then the fault can only be in the airbag module. If the circuit displays less than infinite or any resistance value, then proceed to the next connector in line and disconnect. If the resistance value is still present, then the fault will be between the airbag connector and the last disconnected connector. If the meter value changed to infinite or open when disconnected, then the fault lies between that connector and the SRS control module connector. Perform a visual inspection of the SRS harness connector and all terminals on the SRS control module for damaged or bent terminals. Once the fault has been rectified, ensure all connections are secure and assurance locks are in place before enabling the system. If replacing an SRS control module, be sure to follow the manufacturer's procedures and perform all programming with yourself and the scan tool outside the vehicle. Clear all fault codes and confirm all conditions for running the DTC are met before rechecking. These systems can be extremely dangerous. Follow all safety precautions and do not take unnecessary risks. Never apply any form of voltage to a live airbag circuit. Remember, correct diagnosis ensures an efficient and cost-effective repair. Thanks for watching.